Hello, I'm Phuong.
I'm Yunwei.
I'm Trinh, and this is our research in predicting an individual's risk of heart disease using various machine learning models.
Heart disease is the leading cause of mortalities worldwide. Not only this disease is costing lives, it has also taken a toll financially. In the US, billions of dollars are lost due to the cost of healthcare service. Thus, being able to predict one's risk of heart disease early is important. In our research, we sought out to find a common diagnostic solution that is quick, can alleviate financial burden, and can be used to generate a preventative plan. Inspired by a research study by Dr. C. Lata and Dr. S. Jiva, we want to implement machine learning algorithms to help predict an individual's risk of heart disease.
Through our research, we hope to answer the following questions. 1. Which machine learning algorithm can best predict the risk of heart disease? 2. What is the correlation between each feature and the prediction of one's risk for heart disease? And 3. Which feature is determinant of an individual's health risk?
We first converted the .data file into a CSV file for our Python files to take in. We then replaced values in the prediction column to zeros and ones. For part 1 of our research, we trained 3 models using this clean data set with all columns except prediction, one hot encoded as the features. We compared the efficiency of different models by running several trials and outputting the mean accuracy scores. For part 2 of our research, we calculated the Pearson correlation of each individual feature and the label. We then conducted an ablation study. There, we first found the control group by using all attributes except prediction as the features and tested the average accuracy scores. We then took out one attribute from the features to test how effective the models are without that attribute. Each time, we fed the new set of features into the 3 models to find average accuracy scores.
For part 1 of our research, we found that the Gaussian naive Bayes was the best model, followed by the random forest and the decision tree. For part 2 of our research, we found out that the state of thalassemia, a blood disorder, has the strongest correlation of 0.527 with the risk of having heart disease. Moreover, we also discovered an interesting fact that among all the other attributes, the maximum heart rate achieved is the only attribute that has a negative correlation of negative 0.424 with the risk of having heart disease. In addition to the correlation calculation, we also conduct an ablation study with the hope of finding the determinant feature of the risk to an individual's health. Unfortunately, from the study, we cannot find any distinct feature that significantly impacts the accuracy score of the machine learning models. The only notable finding that we have from this study is that in the naive Bayes model, the highest difference was a negative 0.05 when chest pain type was removed. Even then, this value is minuscule.
There are 2 possible pathways we can take to expand our project. The first one being improving the models with ensemble techniques. Ensemble techniques are algorithms that combine machine learning models into one in order to discrete the variance and bias. Another approach would be to extend part 2 of our project. We can seek out to find why our results from part 2 disagree. Both of these ideas are viable and can help us further reach the goal of this research.
Thank you for tuning in. If you have any inquiry, please email us.